Terminologies. Hello friends, I am delighted to have you back on my channel Certheads and second video in this series SAP on Azure. In this video series, we try to focus on some common terminologies which you will come across most commonly while working on SAP on Azure implementations. We would also try to cover certified configurations and some basic architecture and understand how we can set up a small production environment for a NetWeaver kind of a setup in Azure. Without further delay, let's get cracking. What is an ERP? Let's first take a bird's eye view of ERP as a whole, then we dive in deep into SAP ERP and so on. So we will see certain functions coming up on the screen: human resources, advertising, planning, finances, sales, inventory, accounting, project management, supply chain management. And all of them comprise of one whole single thing called enterprise resource planning. So what is an ERP? Say you are planning to open up a manufacturing business and you want to manufacture plastic goods. All good. Then where do you start? Well, you need to have certain functions in order to set up the organization or enterprise. First is, as you can see, human resources, to hire new people, to manage payroll, etc. Finances, to manage cash inflow and outflow, profit or loss. Advertising, in order to reach out to your customer base. Sales, to manage your sales of your product. Planning, to plan your product. Manufacturing and other related functions. Project management, to manage internal projects or handle bulk orders. Supply chain management, to actually deliver your product to the customers. Accounting, to keep tab on what is being spent. And finally, inventory, to have an understanding of how much finished goods you have versus orders and raw material management. All of these components comprise of an enterprise, and when these components work together to produce value for the business, it's called enterprise resource planning. That is a full form of ERP. As you can see, these are core business processes which are essential to run an enterprise successfully. So what is an ERP? At its most basic level, ERP helps us manage efficiently all the varied business processes in an integrated fashion. Now we agree all these systems cannot run in isolation, they need to be interconnected. The data needs to flow between these systems and applications, and hence we need one software which can interconnect all these varied functions and provide us a holistic view of an enterprise. This is where SAP comes into picture. SAP was developed in 1972 and it has since come a long way. SAP stands for Systems, Applications and Products in Data Processing. The specific vendor for ERP software which develops enterprise software to manage business operations. Now what is cool about SAP is a range of applications it provides to manage each aspect of ERP. On top of that, it allows you to customize these as per your specific business needs. What this essentially does is collect and process data from all the company functions on one platform. This is critical since it allows all the departments to communicate with each other. This helps streamline the business processes and improve data accuracy. It also provides better insights, better understanding of the finances and your inventory, and it is one thing that brings all of them together. Now that we have a high-level understanding of SAP, let's dig in deeper and understand some common terminologies and their meaning. Landscape, systems, environments, components, SAP ABAP or Java components, and NEDB. Now what are all these? Let us talk about each of these. Landscape is all the SAP assets in your IT environment, including production, non-production systems, commonly referred to as landscape. Systems are combinations of applications and databases in your landscape. Environments are grouping of business functions. So as you can see, dev, quality assurance, training, and production. Components, these are individual SAP applications such as ERP Central, ECC, Business Warehouse, Solution Manager, and so on, to cite a few examples. Now these components are based on two types of models primarily. ABAP based. ABAP is basically an language, a programming language, which is inbuilt in SAP, and SAP also supports Java based applications. AnyDB refers to any database which is chosen to run SAP, which is a non-HANA database. So what is HANA? HANA is basically SAP's own in-memory database function, and if you choose not to use HANA, then you can use AnyDB. In AnyDB, there are certain databases like SQL, NoSQL, Oracle, etc. SAP allows you to use certain databases, some certain certified databases, which we will look in the preceding slides. First, let's look at some prerequisites which is required for you to have support from SAP. The first prerequisite is licensing, sizing, certified VMs, certified operating systems, network bandwidth, support agreement, and technical experience. Okay, now let's understand each of them separately. Now, SAP support is required, and why is it required? SAP support is an important part of the game since it includes configuration, support, maintenance of entire SAP software that is implemented in your current IT landscape. Following elements are required: licensing for SAP software which are to be deployed, SAP system sizing and knowledge of resources requirements for SAP. So SAP has very specific requirements for it to run its workloads, and you should know the size of the virtual machines which you are going to use. Certified VMs. Now SAP itself has gone and certified certain VM SKUs in Azure to help you do the implementation. So you should use only the certified virtual machines. Details about SAP certified and supported HANA hardware data is available in the link in the description section. Certified operating systems on which SAP workloads will be deployed. Sufficient network bandwidth. SAP doesn't like latency at all, so sufficient network bandwidth is very important. As much as possible, you should reduce latency. Support agreement with SAP and the cloud provider. Now, apart from licensing, you should also have a support agreement. Technical experience is paramount. You should have people with technical experience on SAP systems and cloud provider infrastructure. So both Microsoft and SAP have documentation on what is certified by SAP, but SAP documentation will always be the source of truth for their configuration, which is a combination of SAP products, operating systems, databases, and Azure VM SKUs. I'll be pasting the links in the description. However, point to be noted is some of the SAP configurations are presented in SAP notes, which can be accessed only with an SAP ID. For examination purposes, you can refer to Microsoft documentation, which is freely accessible. But when it comes to implementation, it is advisable to refer to the latest SAP notes. Now let's take a glimpse on some of the certified virtual machine SKUs of SAP environment. The SKUs are something which is called as a stock keeping unit. Now NetWeaver certified DV and DAV4 for compute intensive workloads, dev test. NetWeaver certified and HANA certified EV and EAV4 VMs, which are memory optimized for dev test and POC HANA workloads. NetWeaver certified and HANA certified M and MV series optimized for large and extra large workloads. Now let's understand what is a SKU. Well, in Azure, the virtual machine SKU refers to a specific version of offering within Azure. It tells us the characteristics of the resources, and a resource can be anything like a virtual machine, load balancer, web application, etc. SKU of the VM tells us about the CPU, memory, IOPS, and storage characteristics of that VM. SAP has a very specific guideline on what SKU can be used to run their software. So here what you see here is the SKU of the VMs and the supported configurations, which are on the right hand side. Now in a gist, you can say if you are trying to run something like a development or a quality environment, which is less memory intensive, your database workloads will not be really having much load, then you can use compute intensive and DV and DAV4 VMs. For memory optimized VMs like EV and EAV4, you can still use for dev test and POC purposes, some light production workloads as well. These are more suited for database kind of a VMs, database kind of applications. And if you want to run heavy or large production workloads or extra large production workloads, then you should be using a M and MV4 series. Now let's understand some certified operating systems. Under Microsoft Server, we have 2008 and 2008 R2 and 2022. SUSE, which is a popular option for HANA. It's SLES, it's also called SLES. So with SLES 12 and SLES 12 for SAP applications is supported and onwards. Red Hat, which is again a popular enterprise flavor of Linux. Red Hat Linux 7 and Red Hat Enterprise Linux for SAP applications 7 and higher are supported. For Oracle based implementations, Oracle Linux 7 and 8 are supported, but there is a catch. You need to have that in combination with Oracle DB. So that's the supported configurations for operating systems. Let's have a look at a small reference architecture. On the left hand side, you can see an on-premises network. On the right hand side, you have your Azure subscription, a primary region. You have a hub virtual network, gateway subnets inside the virtual network, a shared services subnet as well. You also have a spoke virtual network. Before that, you have a gateway which connects on-premises to Azure. You have Bastion and DNS, which allows you to connect to the VMs which are inside your network. In spoke, you have application subnets, and there is a database subnet as well. And you also have NSGs to control the flow of data between the subnets. Now the spoke and the hub are connected with VNet peering. There's a secondary region as well, which contains your disaster recovery, which should contain your disaster recovery workload. Now let's understand this architecture. This is a network architecture primarily. We want to have a look at a reference architecture in 3 different phases. The first phase, we are looking at the basic network setup. In the next, we will add some resources to it. And the third, we will look into the functional flow of the architecture. Great. Now let's take a close look at the networking layout. Here, on the left hand side, we see on-premises network, which is our main office. On the right hand side, there is an Azure subscription, which we have recently procured for managing our cloud resources. In this architecture, we use a hub and spoke topology of the networking to set up a communication between on-premises data center and cloud data center. The hub, the reason we are using hub and spoke is more security. We want to make sure that all the traffic from external world lands onto the hub network. So that's the reason we have created a hub virtual network. Now you might ask, what is a virtual network? A virtual network is short form VNet, is a logical representation of your network in cloud. In Azure, it's called VNet. It allows you to define your own private IP address space and also segment the network into subnets, which are essentially subsets of a VNet. In this example, we subdivide the hub network into 2 subnets, namely gateway subnet and shared services subnet. Now, the gateway subnet will contain the gateway which will be used to communicate between the on-prem and Azure data center via a dedicated channel called Azure Express Route. We create a shared services subnet which has Azure Bastion, which will help us securely connect to the VMs in Azure data center, and DNS service, which will help in the name resolution. Next, we create a spoke network, which basically contains the application subnets and the database subnets, and we peer the hub virtual network with the spoke virtual network with something called as a VNet peering. Now you might ask, what is this VNet peering? The peering is essentially when you join two isolated VNets, because when you create a VNet initially, it's isolated. It doesn't communicate with any other thing until and unless you force it to communicate. So in order to communicate or make sure the two VNets can communicate, you set up a VNet PNE, and you can control the flow of data between the VNets using a firewall as well. Now you would ask, why do you need to create two separate VNets, hub and spoke? Why can't we create a single VNet and have everything inside that VNet, like gateway, shared services, application layers, and segregate it? Well, that is the beauty of hub and spoke architecture. Hub and spoke architecture protects the spokes VNets from external attacks by segregating the VNets. Now all the traffic lands on the hub network, and this is where you would have place your firewall as well, so that you can filter all the traffic which goes into the data center. When I say data center, your Azure data center. Subsequent spokes will be chained to this particular hub virtual network. Hence, it will provide a segmentation in the network. Segmentation is one of the important security principles of your network architecture. So what about the subnets? Should we allow free flow of traffic between the subnets? No. Ideally, only the applications, subnet resources need to communicate with the database subnet. Hence, we control we control or filter the flow of traffic between subnets via network security groups. It's called NSG, short form. In NSG, you can define rules which filter out traffic, and hence you can control which traffic inbound and outbound can flow in and out from the network, basically from the subnet. NSGs can also be attached to VMs, but it's preferable to attach an NSG to a subnet. It makes the architecture much simpler. We create a secondary region in another VNet and subdivide it into subnets to create a disaster recovery setup. Now that we have taken a look at the network, let's include some resources, shall we? Now remember, every component that we create in Azure is called a resource. So VNet is a resource, NSG, Gateway, Express Route are all resources, and the resources need to be part of the resource groups. And the resource group need to be part of a subscription. So if you look at the hierarchy, you have the subscription, then you have the resource groups, and then you have the resources. So this is just to logically group all the resources together. Good. Now let's look at the diagram which has a lot more resources apart from network. So you can see there is a virtual network peering between the resources, and the traffic is flowing from dispatcher pool to central services cluster, and then it is flowing from the application VMs via the the subnets to the databases, and there is a shared services. There is a SMB3 Azure file share as well for high availability. There's a database replica in the secondary region as well. Now let us understand this diagram a bit more. Now we understood hub and spoke. Now we know that on the right hand side where you have all the application servers is the spoke network. So if we look at the spoke virtual network, we have SAP Web Dispatcher Pool VMs, SAP Central Services VMs, and Application Pool VMs. The SAP Web Dispatcher is used for load balancing SAP traffic among SAP application servers. SAP Central Services are run on VMs in application tier, since they are potential single point of failure if deployed on a single VM. Hence, there are two VMs which are created. Now these two VMs will also be clustered at OS level, and there is an SMB file share which helps it achieve a high availability. Central services need to be in a Windows failover cluster in this case. The database tier runs on any DB, which in this case will be Microsoft SQL Server. There is a load balancer in front of the database as well. It will distribute the the application layer traffic in the database. The load balancer in this case, however, will only allow any one database to get the data when the application queries for it. The second database which you see in your primary region will be a backup database or a active database. It will be active, but the queries will always go to the primary database. In case the primary database goes down, the secondary database will come into picture. Now, there is an application gateway as well in front of the SAP Web Dispatcher pool. This application gateway is a web traffic load balancer, right, which you see in front of the central services is a layer 4 load balancer, layer 4 of the OSI layer, and the application gateway is a layer 7 load balancer. Since this is an active passive deployment, the secondary region is also created and the resources and data are replicated using Azure Site Recovery. Now you can see in the secondary region the VMs are being kind of shaded out. The reason is these VMs are not active. They will only become active when there is a disaster and when you switch over from your primary region to the secondary region. However, the SMB file share is an active and the database is active. Now you might ask, why is the database active? The databases cannot be replicated with the site recovery. Now you need to always have the database up even in the secondary region as well. In the primary region, there will be something called as a replication service, which is specific to each database. In case of SQL, it is always on availability group replication. In the primary region between the two databases, the synchronization is via AOAG synchronous process, while in the secondary region the database replication is via AOAG asynchronous process. There is a HANA system replication and Oracle Data Guard system replication, which can be used for HANA and Oracle databases respectively. Now let's look at the functional flow. Now the functional flow, you can see that there is a user and the user is getting authenticated to the Web Central services. You might want to pull a report and the request is sent to the app servers, and then it goes to the SQL server, and from the SQL server there is a replication which is happening via SQL servers always on. That's a synchronous replication, and then the same server is sending the data to the secondary region server, which is an asynchronous replication, and the user is going to get the reports back via the central services. Now let's take a closer look. Now say the user wants to generate some sales report from SAP systems on premises. From on-premises, he is sending out a request to the Azure landscape. The SAP application user will authenticate on-premises with the Azure single sign-on credential. There is an express route gateway which connects on-premises to Azure virtual machines and the resources securely. Sales order requests flow into highly available SAP App Central services and then through SAP application servers. The request moves from SAP app servers to SQL Server running on primary Azure VMs. SQL Server data is stored in high performance Azure premium storage. So premium storage gives you a 99.9% availability as well. At the same time, the SQL Server is also clustered to a secondary SQL Server in the primary region. That provides you another level of security and another level of high availability, which is 99.95% availability. Data replication is handled via SQL always on in synchronous mode. The SQL Server data is also replicated to disaster recovery regions over Azure backbone network. So the secondary region replication happens over Azure's own internal backbone network, which is much faster in asynchronous mode. Point to be noted, the disaster recovery virtual machine can be smaller than the production virtual machine. There is a cost consideration. If you keep a bigger VM, you may incur a lot of costs, so you can reduce the size of the VM. In case of disaster, the VM can be upscaled with minimal downtime. That brings me to the end of the slide, and thank you so much for watching this video. What we understood in this video is various terminologies used in SAP. We understood SAP certified configurations and a simple architecture to deploy SAP on Azure. Thanks for watching, friends, and I will see you in the next video. Till then, take care and happy learning.